Hi everyone, welcome back. And today we'll be doing this question called Maximum Subarray. And this is part of our series, which is a collection of questions that I've collected from Reddit and other places. And it's a medium rated question. So let's just jump straight into the question, which is we are given an integer array, nums, and we need to find a subarray that has the largest product and return the product. We don't need to return the constituents of the product, and we need to make sure that the subarray is a contiguous non-empty sequence. And yeah, this is just them saying that the number won't get too big. And mainly, let's just go through the test case so that we explain the question a bit more. In this series, 2 times 3 gives us the biggest value. Anything other than that will give us a negative value, or like nothing bigger than 6. So yeah, this will give us negative 12, this will give us negative 6, this will give us negative 8. And yeah, no combination of it gives us a better value than 6. Over here, no combination of this gives us a better value than 0 in itself. So if we combine all three of them, we'll just get 0. We cannot exclude the 0 is what this test case is trying to prove. So we attempted a similar question previously, which is maximum sum subarray. And for that, we had the help of this algorithm called Kadane's algorithm. And the logic behind Kadane's algorithm, let me just quickly explain it for those who need recapping, which is it mainly asks us two questions every time we see an item in the list. And we'll just see the list once. Like we'll go through it once only. We won't be going back and forth. So the time complexity of it is efficient, which is just O of n. We'll just see every item once. So what happens is at whenever we see an item, we just compare against the current subsequence that we have in the past. So is this value better to start a subsequence from here, or is it better to work together with the previous sequence that we have? So is 2 better, or is 2 better working with what happened in the past? Since nothing happened in the past, we can just start from here and we look at 3. So is 3 better on its own, or is it better together with the rest, which is another positive value? So 2 plus 3 is 5, and 5 is better than 3. So we'll just work together. We'll just team up together and go on. And we see negative 2. Negative 2 isn't better on its own, and it just works better together with the rest because even though 5 is bigger than the combination of this, which gives us 3, we need to keep track of the 3 as a current maximum and keep track of 5 as the global maximum. So the logic is just we'll keep track of what is the maximum seen value before and return that. But while we are traversing through, we'll keep track of what is the current most possible value up till this point. Like up till if we were to include this, what is the maximum that we can possibly get? And as we go along in that sequence, at some point we will see the maximum most sum subarray. So in this question, we don't need sum, we need product. So we'll be doing something similar, but we'll not just be keeping track of the current maximum, we'll keep track of the current minimum as well. So maxi and mini. So I'll just code it out as I explain. We'll be instantiating with 3 variables, which is maxi, mini, and result. Res is just the final result that we will be returning, and this is the global maximum that we're keeping track of. And we'll be running through this in a for loop for num in nums. I will ignore the first item because the first item has been processed over here. They are already assigned, like maximum, minimum, and result is all holding this already. And what I will do is I'll keep track of a current maximum. Is the current maximum maxi multiplied by num? Or is it mini multiplied by num? Or is it just num itself? And we will do this the same for the minimum most value. So you may be wondering, why do we even do this? Why do we need why do we need to keep track of the maximum and the minimum? And the reason is because in the product, when we are trying to find the product, the presence of a negative value can just flip the whole thing. From the largest most value, it can just when you multiply with the negative sign, it could just flip all the way to the bottom. It could all of a sudden become the minimum most value. And likewise, the minimum most value can just flip and become the maximum most value as well. That's why At each instance, we're looking at the current maximum, multiplying it by the number, and the minimum most value and multiplying by the number, and we just put the number itself. Out of these three things, we get the maximum and assign it to the current maximum. Same thing, we will do the same thing for this. The minimum most value of these three items will get assigned to current minimum. And having done that, now we will assign it back to the variable that we instantiate at the top. Car max mini is car min. And the global maximum will keep track of the global. Is it the maximum most value in the entire list? And after that, we can just return result and it should work fine. So let's run it through an example test case as well. Let's say this is the test case right now. Okay. So we instantiated it with maxi is equal to 2, mini is also equal to 2, and result is equal to 2. So we this is our starting point at this juncture. As we go to num1 onwards, so from here to the end, now the num value is 3. When num is 3, the current maximum is maxi multiplied by num, which is 3, so it's 6. This is also going to be 6. This is going to be 3. So the maximum most value is going to be 6. Over here, the minimum most value is either going to be maxi multiplied by 3, which is 6, mini multiplied by 3, which is also 6, or is going to be the number itself, which is 3. So mini is now going to become 3. And as we go along, next item, which is -2. Maxi is going to become maxi multiplied by -2, which is -12, or it's mini multiplied by -2, which is -6, and -2. So of these three things, the maximum most value is actually -2. And mini will become, I think, maxi multiplied by -2. So the previous maxi was what? Was 6. So 6 will become 12. -12. Well, this will become -2. So it's a bit convoluted like that, but as we go along, we will find out that, oh yeah, I forgot to do this step, which is result multiplied by maximum of result itself, which is 2, and the maximum that we saw previously, which was 6. So the global maximum gets updated to 6. And as we go along, we will find no other combination gives us the maximum most value to beat 6. And hence, the answer is 6. Now, if we had just put -1 into this mix, what would have happened is the minimum most value would have been 48 until we reach the last item. The minimum most would have been this, or the maximum would have been something. But once we multiplied this, the mini multiplied by -1, this will be 48, and nothing is bigger than 48 in the combination that we have seen so far. And hence, this will get assigned at this stage, and that'll be the largest answer. I hope that that helps visualize things a little more. But let's try submitting this and making sure that it passes all the test cases. And yeah, so this solution is, in terms of time complexity, it is n time complexity because we're only seeing each item just one time. And these are all just comparing against a size of 3. So this is also like, it's negligible. So it's effectively just n time complexity. And in terms of space, we're not allocating any new arrays or anything new. So it'll also be constant. So it's n and n time complexity and constant space complexity. So yeah, there you have it. This is my attempt at doing this question, maximum product subarray. And let me know if it helped you guys, or if you were more confused by my explanation, let me know as well, and I'll try to address them in the comments. And until next video, I will see you guys later. Yeah, bye.